Right. Yes. Yeah, I hope you had a good holiday today. Yes. Until you met me today in the evening. Yes. How are the things? I hope everybody can hear me. All right. Yes. Can you all hear me? Yes. Good evening. Yes. Everybody, right? Shall we start our discussion? So this is on this tutorial. This is the tutorial. Like, next week I'll give you a separate paper, right? This also contains a lot of MCQs. I thought it is a good time that we should actually discuss this. So we are looking for an hour plus little bit more. My plan is to discuss up to 30 questions. We'll see. We'll see how we can progress, right? It all depends on how well you can grasp and all that. So I hope everybody can hear me okay. The connection is all right. Everybody? Come on. Yes. Right? Yeah. Waiting for your answers. Right. Okay. Good. Looks good to me. Right. So we'll start with the question number one. Right. Very good. Start with the question number one here. Let us say we will take that one question number one here. So read that question. It says radius of bromide ion is 1.95. Radius of bromide ion is 1.95 angstroms. What is angstroms? Bromide ion is 1.95 angstroms. Angstroms. Angstroms is how much? How much is an angstrom? 10 to the power minus 10. Yes, 10 to the power minus 10. We don't need it. I just reminded you. Interatomic distance of KBr. So you have a potassium here, and then let us say you have a bromide as well, right? So Br minus. These are ionic compounds. So interatomic distance here, or interatomic distance, they say 3.28 angstroms. So meaning the radius of potassium plus the radius of bromide, add them together. That will give you 3.28. Can you tell me what is the radius of potassium? What is the radius of potassium? 3.28 minus 1.95. What is that answer? What do you get? 3.28 minus 1.95 gives you, what is the answer? Yes, 1.33 angstroms. So if you know the radius of potassium, they say KCl is 3.14. So KCl. So this is your potassium K, and this is your Cl. Right? This is your Cl minus. This is potassium. That distance, interatomic distance, not the diameter, but the radius, addition of the radius. So radius of potassium plus radius of Cl minus is equal to how much? 3.14. 3.14. Potassium, you know. So RCl minus is equal to 3.14 minus 1.33. What is that? 3.14 minus 1.33 gives you 1.81 angstroms. 81 angstroms. So therefore, it is the fifth answer. Like, I have mistakenly taken it as A, B, C, D, E, but I hope that is not a big issue. So our answer is the fifth answer, E, right? E is the answer. Everybody understood that, right? Is it clear? Right. Okay. So I will give you the answers next parts. Like, if you want to clarify them, please make sure you ask them, right? Question number 2. Question number 2, it says, the second ionization energy is the lowest in group 2 elements. What can you say? Right? Part A, second ionization energy is the lowest of group 2 elements. I think that is a right statement. Yes, lowest in group 2 elements. That's true. All elements have a second ionization energy. What can you say? right? What can you say? All elements have a second ionization energy. Now, for example, hydrogen doesn't have a second ionization energy. So that is wrong. So that is wrong. Hydrogen is the exception. Even helium has second ionization energy. Hydrogen is an exception. C, part C. Second ionization energy of an element is always greater than the first ionization energy. What can you say about that? It is true because the effective nuclear charge or the electrons experiencing the nuclear charge increases. So therefore, it is a true statement. What about D? Second ionization energy is always endothermic. Endothermic means heat is absorbed when the second ionization energy is there. That's wrong. No? Is it wrong? False. Endothermic is false. I think that is a true statement. Why? Mama buru kiyanawa. You have to be very careful, right? So what you have is it's a nucleus. There is a nucleus. If you have an electron is always attracted to the nucleus. So you have to break it out from the nucleus, from the attractive force. So it will supply energy. You need to supply energy. D is a right statement. It says endothermic energy is absorbed when you are doing that. Everybody agree with that? E E is the first ionization energies of the D block elements generally increases. What will happen? First ionization energy of the D block elements generally increases across the period. What would happen? Across the period, radius decreases. So generally it increases. E is right. F, the radius of elements in the period increases across the period due to the increase in the effective nuclear charge. What can you say? Across the period, radius of the elements in the period increases. What can you say? Across the period, radius decreases. I gave you this shape. Like, usually the radius decreases like that. So that's a wrong statement. Yeah, decreases. Copper has a lower first ionization energy than zinc. That is true. Copper and zinc, they are closely related. And EFG is copper has a lower first ionization energy. What will happen? Lower first ionization energy is what? Is it a true statement or a false statement? I think copper has a lower first ionization energy is a true statement. Zinc has a slightly higher first ionization energy. So that's a true statement because compared to copper, zinc has a lower radius. Right. Okay. Anything there? Like somebody says, I think E is wrong. First ionization energy of the D block elements generally increase. Yes, that is true. Generally increase. The general trend is to increase. That's a true statement. Across the period, radius decreases. So that first ionization energy generally increases. Generally, it says, not very specifically, generally increases. Anything else that you want to double check, cross check? Can you explain the part B? All elements have a second ionization energy. Hydrogen doesn't have a second ionization energy. Hydrogen doesn't have a second ionization energy. There are no two, you have only one electron. How can you remove the second electron? Right? You can't remove the second electron. Did you understand that? Right? Can you explain E? The first ionization energies of the D block elements generally increases. Across the period, radius decreases. Across the period, radius decreases. So what will happen? The ionization energy increases as well. Right? Okay. Question number 3. Right? Okay, so let us look at the next one. Right? State whether the following statements are true or false. Across the period means copper is greater than zinc. No. This is how you have scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. So across this copper and zinc, if you look at it, the radius is higher for copper. Zinc has a slightly lower radius. So you have that. Okay, right. So third one, the ability of an, okay, so true and false statement, right? The ability of an atom to attract electrons towards itself in a bond is known as electronegativity. What can you say? What can you say about that? The ability of an atom to attract electrons towards itself in a bond is known as electronegativity. I think that is a true statement because that is what you mean by electronegativity, right? Next one, electronegativity of an atom depends on the environment of that atom. That is also true. It depends on the surrounding electrons, surrounding atoms as well. I will give you a better explanation in bonding. When there's bonding, I will explain this better. Like, we'll explain it better in bonding. Explain better in the section of bonding, in bonding. Environment means how it is bounded to each other, right? See, electronegativity decreases as the radius of the atom increases. What can you say? Electronegativity decreases as the radius of the atom increases. As the radius of the atom increases, electronegativity decreases. That's a true statement, right? So when you go down the group, what will happen? Electronegativity decreases as the radius of the atom increases. So here the radius is higher, radius is even higher. So what will happen? Electronegativity has decreased. Radius increases, electronegativity decreases. That's a true statement. D. Beryllium has the highest electronegativity out of S block elements. Be very careful and tell me. Beryllium has the highest electronegativity out of S block elements. What are the S block elements? We have lithium, sodium, potassium, rubidium, cesium. What else? You have beryllium, magnesium, calcium, strontium, barium, but don't forget hydrogen also. You have hydrogen as well, right? So if you look at this, hydrogen electronegativity is 2.1. This is 1.0 and this is 0.5 difference, 1.5. Sodium is 0.9. Magnesium is, you remember, 0.3, right? 1.2. So highest one is hydrogen, not beryllium. So that is a false statement. That is wrong. Did you understand that? Hydrogen also belongs to the S block. It's a S block element, not a metal, but it's a S block element, beryllium. And E. What can you say? Electronegativity increases when going down in the group. What do you say? When you're going down in the group, electronegativity increases, it says. Well, again, everybody should, you should answer. Right? What is your thought? Yes, it says electronegativity increases when going down the group. That is wrong. It is going to decrease. Yes. Maximum electronegativity for an element in group 17. What can you say? F. What can you say? Maximum electronegativity is for a group 17. I think that is right. 17 is fluorine. Yes. There is 0 electronegativity for group 18 elements. True or false? Last one. There is a 0 electronegativity for group 18 elements. It has a low electronegativity, but you don't consider it as 0. No value is given. G, that is a wrong statement. Everybody understood that? Right? No, not 0. Almost 0, but not 0. Right? Okay, right. Is it clear, everybody? Right. Then let us go to the next topic, question number 4. See what is going to happen here. Question number 4, right? It says, right. So here plus F minus, O2 minus, and Mg plus 2. What is the first thing that you check for? what is the first thing that you check for? Energy levels. Sulfur, how many energy levels? Can you tell me what is the number of energy levels? Very quickly. Sulfur has 3 energy levels. Sodium plus has how many energy levels? Sodium plus has 2 energy levels. Fluoride also have 2 energy levels. Oxide have 2 energy levels. Magnesium also, after removing 2 electrons, you have 2 energy levels. From that itself, you can tell what is the largest radius. Which one is the largest radius? The largest radius is for sulfide ion. Everybody got that answer? Clear? Everyone? Right. Oh, very good. Very good. Question number 5. Question number 5, if you look at it, tell me what is your thought on this. Huh? Right. Which out of the following has the highest first ionization energy? Which one has the highest first ionization energy? First ionization energy, you usually vary, right? Okay, usually vary according to what kind of a pattern. It's a zigzag pattern. Group 1, group 2, group 3 drop, 4, 5 drop, 6, right? 1, 2, 3, 4, 5, 6, 7, and 8. So usually you have a very high first ionization energy for group 18 elements. Group 18. 18 elements is the one that is having a very high energy. Now there are 2 elements with group 18. One is neon, the other one is xenon. Which one has a higher first ionization energy? Neon or xenon? Neon, why? Because it has a lower radius. Yes, neon is the answer because it has a lower radius. So I will write down that lower radius. Is it clear? Did you understand that? Everybody? Yeah, right. Very good. So that was question number 5, I think. If I miss a question, please tell me. Yeah. Question number 6. Read this and tell me how this is going to work. Which element out of the following has the highest second ionization energy? Usually highest second ionization energy is given for what? Highest second ionization energy is given for what? Right? Yes. Alkali metals. Alkali metals. So out of this, which one is the alkali metal? Which one is the alkali metal? It is for sodium. So I think sodium is the right answer. Everybody okay with that? Is it clear? Right? Did you understand that? Sodium, like when you look at 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s1, and sorry, the sodium, right? We are writing for sodium. What is that? 1s2, 2s2, 2p6, 3s1, right? 3s1, right? 3s1 means you have now already, now when you are removing the second electron, you have now removed the first electron. So this is what you have, right? Yeah. So this electron is removed. 2p6 is removed. And now there is a bigger charge in it. There is a higher charge. This is like the argon configuration. Helium, neon, right? Neon configuration. This is like the neon configuration, right? Compared to argon, neon has a smaller radius and the number of charges is very high. And then you are breaking that octet. So therefore, it should have a very high value, not argon. Argon is somewhere else. It's in that corner, right? If you look at it, let me get the periodic table also. Argon is in the third period. So it has a kind of a bigger radius. Sodium, when you remove it, you get the neon configuration. It gives you the neon configuration. Neon configuration, and also there is a positive charge. So 8 electrons, they are much strongly attracted as well. Much strongly attracted as well. So when you try to remove that electron, you need to supply a large amount of energy compared to argon. So not argon, sodium is the answer. Did you understand that? So what is that? Sodium is your answer, right? Question number 7. Let us read question number 7. A, B, C are 3 non-transition elements that belongs to the same period. They belong to the same period like that, A, B, C. We don't know what sequence it is. A is a non-metal. A is a non-metal. B is a metal. And C shows both metallic and non-metallic properties. When they show both metallic and non-metallic properties, what are they called? What are those elements called? Yeah, they are called metalloids, right? They are called metalloids. So in a periodic table, how are they arranged? If it is in a single period, how are they arranged? In this corner, to your left-hand side, what do you have? To the right-hand side, what do you have? You should have, on this side, you should have metals, isn't it? These are metals. Then, what is the next thing that you should get? You should have what? Metalloids. Ah, the wrong choice of color. Metalloids. And then you have, what else do you have? In this corner, you should have non-metals. So based on that, we can look at this. Metal is B. So B is in this corner. Metalloid is C. A. B, C, A is your answer. Is it clear? Metal to metalloid to non-metal. Everybody understood that? Right. Okay. Excellent answers. Thank you very much. BCA is the answer number C, right? Question number 7, right? Question number 8. Question number 8. Okay. Right. Let us see this one. We have to be very careful, right? Slowly listen to this. W, X, Y, Z are successive non-transient elements. That successive non-transient elements means they are located next to each other. But non-transient, not D block elements, no, not F block elements. They are main group elements, S and P. Right? What are these? W, X, Y, Z. They are close to each other. Right? One after another in the period. Periodic table. Their first ionization vary. W is greater than X is greater than Y. W is greater than X. It says W is greater than X. X is greater than Y. Right? X is smaller than Y. Right? The W is smaller than X. X is smaller than Y. And they don't say anything about Z. Oxide of Z is basic. So it gives you a basic oxide. Now, what are the things that will give you basic oxides? Non-metals or metals? Basic oxides are given by what? Given by metals. So it's a metal oxide. Metal oxide. So you have to understand that Z is a metal. W, X, Y, Z are continuous elements. Right? Let us see how this is going to work. Right? So this one, we are going to plot the first ionization energy. They say they are the first ionization energy vary like that. So this is group 1, 2, 3, 4, 5, 6, 7, 8, and then the first one is here. So I'm going to write that, those numbers. These are group numbers, group 1, group 2, and this is group 13, 14, 15, 16, 17, 18, 9. And this is again group 1. So that is how the variation take place. Let me color this with a different one so that you can clearly see them, right? So like that. Right. Okay. So this is the next one. This is the next one, next one, next one, and this is the next one. And then suddenly it drops here, right? Okay. That line didn't work well, right? Right. Okay. So did you understand that? Everybody all right with this? This is the first ionization energy, I1E. Right. Now, if they say W is smaller than X and X is smaller than Y, you can think about these ones. Now, this is definitely not these ones, no, because, W, X, Y, you can't be these three. The third one drops down. So, can't be that. No? So, this can be W, this can be X, this can be Y, and yeah, so that can be one where you can see W is smaller, X is higher, and Y is even higher. You see a similar trend here as well. So you can see Z has two answers. Z can be this or Z can be this. What do you think Z is? My question to you is that. What do you think Z is? Z belongs to group 16 or Z belongs to group 1? They say Z is a metal. Which one? Which one is that? Yeah, exactly. You are absolutely right. You're amazing, right? Group 1. Yes, not, it can't be this. Can't be that. This is the one. By 16, you have oxygen, sulfur, selenium, tellurium, polonium. These are the ones that are there. Of course, polonium, tellurium, they are metals. But if you look at this, the upper part, it is non-metals. They are non-metals. Yes, it is a basic oxide. Exactly. Very good. Right? So you can have, if Z can be group 2, Y, X, Y can't be 13, 14, 15. 13, 14, 15, Z can't be group 2, no? Because you say, they say W, X, Y, Z are consecutive elements. They are successive elements. They don't say W, X, Y, Z. Z, W, they say W, X, Y, Z. They are how they are arranged. Right? Did you understand that? So Z is the next one. So X, Y, Z. So this is X, this is Y, this is Z, and this sorry. It is wrong. That is wrong. So this is X. X is what? What is that? W. This is W. This is X. This is Y, and this should be Z. Did you understand that? So WXYZ is that. And then what would be the electronic configuration of the last energy level? If oxide is a basic one, what would be the electronic configuration of last energy level? So you're talking about Z, right? Like my mistake. But Z, if you look at the last energy level, what is that? It should be NS1 and definitely NP0, right? Did you understand that? Right? If somebody now you're someone else, there's another one of you, they think Z can be group somebody thought group 2 also, right? Even if you say group 2, you don't have an answer there, right? You don't have an answer for group 2. Right? So only possible out of the possible answers, NS1 is the only answer that is possible. Did you understand? That was a good shout there. That's really good thinking all overall there, right? Isn't this a given? Is a consecutive element? It is a consecutive element. Consecutive element means in the periodic table 1, 2, 3, 4. They are connected together. That doesn't mean that they are in the same periodic table. Consecutive elements are like this also, right? This is also a consecutive element compared to this. After that, it comes here, right? What about second answer, S2P3? How do you get that? You can't get it. S2P3 is, yeah, 2, 13, 14, 2, 13, 14, 15 are consecutive. True. But do you have an answer for 2? What is 2? NS2. Do you have an answer? You don't have answer NS2. NS2, NP0. Do you have an answer? You don't have an answer. So that is why. Out of the answers, you have to select one, right? Everybody understood that? How it became NS1, NP0. Now, group 1, what is the electronic configuration? Group 1, hydrogen, lithium, sodium, potassium. What is the common electronic configuration? This is 1s1. This one is 1s2, 2s1. So electronic configuration is S1 here. Here it is S1 here as well. Sodium 1s2, 2s2, 2p6, 3s1. So you can see here 3s1. Right? NS1, common electronic configuration is that 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 is the next one. Right? So that's a common electronic configuration. So likewise, if you look at this group 1 here, group 2, right? Group 3, 3 means 13, group 14, group 15, group 16, group 17 and group 18. Can you tell me their common electronic configurations? Right? What are the common electronic configurations? Right? What are the common electronic configurations? This is NS1. There's one last electron. This is NS2. 2 electrons in the last energy level. This is S2, P1, 3 electrons. This is S2P2. This is S2P3. This is S2P4. Yes, S2P5. And the last one is S2P6. That is the electronic configuration for that. Everybody understood that? So just consider the order of the English alphabet, and we can't say Z is first before the other. Now there's like nothing to do with the order of the English alphabet. You have to identify this. But then if you consider Z dash group 2, there is no answer for it, right? Right? Did you understand that? Why can't it be 16? 16 doesn't provide a basic oxide. Basic oxides are given by metals. So you can write those, right? When you want to write them, basic oxides are given by metals. Acidic oxides are usually given by non-metals, right? So if you are like doing this carefully, you might want to write that again. Why it should be a metal to form a basic oxide? Metals are the ones that will form basic oxides, right? Yeah. It says WXYZ are successive. How can they be NS2? No, NS2 is not an answer. NS1 is the answer. Yeah, this is the answer. NS1. NS2 is wrong. Does group 13 gives basic oxides? Now, group 13 gives you, what are the group 13 elements? Boron, aluminium, gallium, indium, thallium. These are the group 13 metals. Boron gives you actually amphoteric oxide, B2O3, slightly acidic. Al2O3 definitely amphoteric. It has acidic and basic properties both, right? So there it should be a proper metal to form a basic oxide. So I'm going to erase that out of the purview of the discussion, right? What are the acidic oxide formed by non-metals? Now, for example, look at this carbon dioxide. Is a acidic oxide. Carbon dioxide, when you dissolve it in water, it gives you an acid, right? Carbon dioxide. What else? Phosphorus pentoxide, P2O5 gives you H3PO4, right? P2O5, carbon dioxide. What else? Nitrogen dioxide. Nitrogen dioxide gives you HNO3, HNO2, these kinds of acids. So these are the non-metal oxides. Sulfur dioxide. Sulfur dioxide is acidic, right? These oxides are acidic. Right, okay. So our answer is, first answer, NS1, NP0. Isn't aluminium a proper metal? It is a good metal, but it has both properties because it is in the boundary. It's called amphoteric. It has acidic properties and basic properties. It can react with acids, it can react with bases. Aluminium. Aluminium is amphoteric, right? Okay. So, like, we haven't done those yet. Like, with time, we will look at them, right? So don't worry. But only thing is, even from your O-level knowledge, that basic oxides are formed by metals. Metals form basic oxides, right? Acidic oxides are formed by non-metals, right? Okay. Question number 9. Let's look at question number 9. What is the sequence of which electrons are filled into the energy levels in the fourth period? So, Aufbau principle. Remember, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f. Can you remember how electrons are filled? 5s. I'm sure you can remember this. Like that, right? Like that. Right. So how electrons are filled into the 3D? First one is, what is this? 1s, then 2s, 2p, then 3s, 3p, 4s, 3d, and then 4p. See whether you have an answer there, right? What is that? 4s, 4p, 4d. I don't think that is right. 4s, 4p, 4d. Is that the answer? 4s, 4p, 4d. Yeah, the same answers. 4s, 3d, 4p. What do you think? 4s, 3d, and then 4p. That is how electrons are filled there. So what is the answer? Answer is C. What do you think? Answer is C. Everybody? Right? 3D, what is that? Isn't 3D, yeah, like, period 4. Period 4 is made out of period 4. Let me show you the periodic table. Like the periodic table, like let us see where is the periodic table, right? Okay, so there you have the periodic table, right? So if you look at that periodic table, this is the fourth period. Fourth period is this. Yeah. So fourth period is this. So you have 3D as well. scandium, titanium, vanadium. This is called the 3D, right? 3D, and these are 4Ps, and this is 4S. This is 4S. This is 3D, and these are 4Ps. So that is how you get that answer, right? Okay. So part C, answer C. Okay. Right. Let us go to the next question. See whether you are all right with that. Question number 10. Right. X, Y, Z are three non-transition elements present consecutively in the periodic table. So non-transition elements present consecutively in the periodic table. Their first and the third ionization energies are given below. To which group does X belongs to? So X, Y, Z, these are three consecutive elements. So you have X here, next one you have Y here, and then Z on the other there, right? So if you look at this one, this looks like first ionization energy looks like this. This is the first ionization energy, yeah? I1E, right? First ionization energy, 1012 X. X is 1012. Y is 999. It is lower. Y is 999. And next one, Z is much higher, 1251. So this is Z. Did you understand that? X, Y, Z. So variation is like that. Like that. In the third ionization energy, I will use a different color and write it down. Third ionization energy is 2912, third ionization energy, 3361, and 3000, something like this. It is much higher. Third ionization energy increases, just increases linearly like this. Right. Third ionization energy increases linearly. Right. So keeping that in mind, let us try to work this out. If you look at this in the first ionization energy, how does the variation take place? 1, 2, 3, 4, 5, 6, 7, 8. That's how the variation take place. Can you tell me, where do you see this format, this bend? Where do you see that? Between what and what? This is group 1, this is group 2, this is 13, 14, 15, this is 16, 17, 18. Tell me, where do you see this drop? Where do you see this drop? Between what and what? Yes, you can see that it is observed here. This is the first observation here. That is that. Okay, let me, right? So this is the first observation, right? This is the second observation. This one is the second observation, right? So your X, Y, Z can be 2, 13, 14, or 15, 16, 17. Did you understand that? 2, 13, 14, 15, 16, 17. This is for the first ionization energy, I1E. Let us draw the third ionization energy and see, right? So I'm going to draw the third ionization energy as well here. Like, let us say we will plot this, right? This is I3E, yeah? Third ionization energy is lowest for which group elements? Which group elements? Third ionization energy is lowest for which group? Group 3, yes, group 13. So we say 1 here, 2, 3, 4, 5, 6, 7. So this is, what is that? 13. This is 14. This is 15, 16, 17, and this is 18, right? I will erase that last part there. Did you understand that? This is how the variation take place if it is the third ionization energy. So lowest one is that. I hope you're getting this, right? If it is a third ionization energy, it varies like that. Everybody understood that? Where do you see the linear trend? Is it 2, 3, 14? 2, 3, 14, do you see a linear trend? This one, earlier one is somewhere very high. So that is wrong. Next one is, what do you think? 15, 16, 17, I think they all match. Yes, here it matches. Here also it matches. Look at that. It matches here as well. So which one is the answer? E, A, B, C, D, E, group 15. X belongs to group 15, right? Yes. So X belongs to group 15 and the answer is that. Right, okay. So I saw something like, okay. So there's the same answer is being repeated many times. What about 3D, 4S, 4P? 3D, 4S, 4P is wrong. It is first filled into 4S, then only it is filled to 3D and then 4P, right? That is how it is filled. According to the Aufbau theory, earlier question, according to the Aufbau theory, right? 4S is filled first, then 3D, and then 4P, right? Okay. So X is group 15, right? Everybody understood that? Wow, wonderful, good. Did you understand that? Anyone want me to explain anything that we have done before this, before the 10th question? Everybody okay with that? Right? Is it clear? Any question that you want to revisit? Anything that you didn't understand? Right. Okay. So then we will continue, right? Let us do 10 to 15, the next set of questions. Right. Question number 10, 11. 11. Question number 11. Tell me what do you think about this answer, right? Third ionization enthalpy is maximum for what? Where do you see maximum? Third ionization enthalpy is maximum. Which one has the maximum third ionization enthalpy? What do you think? Maximum third ionization enthalpy is for group 2 elements. Group 2 elements. Group 2 elements. What is that? That is for magnesium. Magnesium is answer number D. Right? Okay. Question number 12. Which statement is incorrect regarding N3 minus O2 minus F minus? Let me write that. N3 minus O. Regarding these things, which one has the true answer? Not true answer, incorrect answer, right? We have to be careful. They all have the same electronic configuration. What can you say? Nitrogen has how many electrons? Nitrogen has 7 electrons, 7 plus 3, altogether 10 electrons. Oxygen has 8 electrons, 8 plus 2, altogether 10 electrons. Fluoride, 9 plus 1, altogether 10 electrons. Right? Okay, they all have the same electronic configuration. I think that is a true statement. A is right. The nuclear charge increases, N3 minus, right, number of protons here, 7 here, this is 8 here, this is 9 here. Does it increase in that manner? Yes. N3 minus has a lower nuclear charge, then a higher nuclear charge, even a higher nuclear charge. That is also right. B is right. They all are isoelectronic with neon. Neon, if you look at neon, how many electrons neon have? Neon has 10 electrons. 10 electrons. So C is also right. They all have 10 electrons. We have calculated earlier. 10 electrons. Their ionic radius changes D. Ionic radius is N3 minus, O2 minus, and F minus. What do you think? N3 minus. That is wrong. Greater the negative charge, greater the radius. You understand that? So here 10 electrons are attracted by 7 electrons. In the fluoride, 10 electrons are attracted by 9 electrons. So it will expand much bigger. So what you have that is the problematic answer. So I will put a red color into that, right? And let us look at the last one as well. That is wrong, I feel. If lithium is reacted with nitrogen, oxygen, fluorine respectively, these ions containing compounds are formed. Yes, lithium nitride, lithium oxide, lithium fluoride are formed. That is a true statement. But then the problematic answer is D. I think answer number D. Would you agree with that? Do you agree with that? Yes. Okay. Right. Good. Question number 13. Let us do question number 13. Right? These small questions, it will help you to understand the concepts better. Right? What is the correct order? 11th. What is the answer? Answer number D. They ask you the incorrect answer. No? Answer number D is the incorrect answer. Right. Question number 13. What is the correct order of increasing the atomic radius? What is the correct order of increasing the atomic radius? They have given some set of elements, oxygen, carbon, aluminium. I'm taking the first one, right? Phosphorus and calcium. First thing that we need to do is we look at the energy levels. Energy levels, oxygen is 2, carbon is 2, aluminium is aluminium. Aluminium is 3, right? Phosphorus is also 3. Calcium is 4. Did you understand that? Right? Is it clear? Right? Energy level is that. Right. What is the next one? Okay. So what is the next one? Next one is the number of protons. Can you tell me what is the number of protons? Oxygen, 8 protons. Carbon, 6 protons. Aluminium, 13 protons. Phosphorus, 15 protons. And calcium, how many protons? Again, how many protons? 20 protons. Electrons? Electrons are 8, 6, 13, 15, and 20. They are never ions. So what is the first thing that we consider? Usually these ones, what is the first thing that we consider? We consider the number of energy levels. If you look at the number of energy levels, calcium is the biggest. 4 energy levels. Then we have to consider aluminium and phosphorus. Aluminium and phosphorus, higher the nuclear charge, larger the nuclear charge, they are attracted towards each other. So if you look at aluminium and phosphorus, which one is bigger? Aluminium or phosphorus? Taggal again. Aluminium or phosphorus? Which one is bigger? Aluminium is bigger, right? Then phosphorus. Now tell me, if you look at carbon and oxygen, they both have 2 energy levels. The one that is having a lower number of protons is carbon. So you have carbon and then comes oxygen. That's your answer. Right? When the nuclear charge increases, radius decreases, increases or decreases. It depends on where do you go. When you go down the group, radius increases. When you go across the period, radius decreases. Same effect. When you go down the group, you are introducing more energy levels. So it will increase. Right? Across the period, you are not increasing the number of energy levels, but the nuclear charge is increased so that it will gradually close by. Right? It becomes closer and closer and closer. Is it clear? Question number 14. right? Yeah. Before that, I think somebody asked this question. Let me. So, can you explain E of the 12th question? E of the 12th question. E here. So, E of the 12th question is: if lithium reacted with nitrogen, oxygen, and fluorine respectively, these ions containing compounds are formed. If you react lithium with nitrogen, it will give you lithium nitride, Li3N. It's a 2 times 3, 6. You know how to balance it. Nitrogen 2 times 3, 6. Lithium plus, what is the next one? Oxygen. Oxygen, yes. Oxygen, it will give you lithium oxide, Li2O. So these containing ions are formed. So 2 here, 4. And the other one is lithium and fluorine. Lithium and fluorine, it will vigorously react and give you lithium fluoride, LiF. So that is why I said that it's a true statement, right? Okay. Question number 14, right? Let us look at question number 14. First one, what can you say? We have to go through this very slowly, yeah? Right? Very slowly. Let us look at that. The covalent radius of iodine is less than its van der Waals radius. What can you say? Covalent radius is whenever it forms a covalent bond. Remember, I told you, right? Whenever it forms a covalent bond, you get the internuclear distance divided by 2. What do you mean by van der Waals radius? When it forms a van der Waals bond, like that. Van der Waals bond, if you look at the 2 nuclei, you take these 2 nuclei, get the interatomic distance and divide by 2, right? That is the van der Waals radius. So this will give you a temporary delta minus delta plus. This is also delta minus and delta plus, right? Which one is bigger? Which one is bigger? Now you all know, understand that van der Waals radius or the covalent radius. What is bigger? Covalent. Sleeping? Ah? Yo. Huh? Sleeping. Van der Waals. That is, that is what you do. Sure. Okay. Which one is bigger? Van der Waals is bigger. So the covalent radius is less than its van der Waals radius. Do you see that? So that is a true statement, isn't it? That's a true statement. I think it is a true statement. Everybody understood that? It is true. Right. Then the second one is this. Second one is first electron. Can you correct? Yeah, like, okay, let us leave it like that. First electron affinity of oxygen is less than that of nitrogen, right? First electron affinity of oxygen is less than that of nitrogen. Right? This is a kind of a little bit of an issue, right? Right? First electron affinity. Remember what is electron affinity? Opposite of electron gain. Electron affinity. I will write that. Just for you to. Now it is not even writing. I have this problem always. When something very important happening, it stops writing. Right. Electron gain is equal to minus electron affinity. Electron affinity. Now, can you remember electron gain enthalpy? Right, we'll do question number 15 and we'll stop. Already 10. I mean, you must be sleeping, right, as well. So we will do, like, we'll do another session. We will work this out, right? Okay, so electron gain is equal minus electron affinity. Electron gain means what? You have some kind of an element. Take 1 electron in the gaseous phase and you get A minus. That is what you mean by electron gain enthalpy. So can you tell me which ones are positive and which ones are negative? Positive ones means you have to work really hard. Like, asking them to study hard. Parents are energy. So it's like that. They are very reluctant to get that electron. Right? They are very reluctant to get that electron. So that absorbs that amount of energy, right? So which one is that? The positive ones. Can you tell me which group? First one is negative. It likes to get. Group 2 is very positive. Group 2. 3 negative, 4 negative, and 15 is negative. Positive, 15. 16 negative, 17 negative, and also 18 again positive. So this is how the variation takes place, right? This is 1, 2, 3, 4, 15, 16, 17, and then 18. So the ones that are positive are group 2. What else? Group 2, 13, 14, 15. Group 15. What is the other one? Group 18. These are the positive ones, right? What is first electron affinity? The first electron affinity means first electron gain means it is gaining the first electron. First electron, the first ever electron it takes. Then you can have second electron gain, third electron gain, like, you can forcefully give electrons. So first electron gain means the first electron, like the first ionization, first electron that is taken, right? So what do you have? 2, 15, 18. It says first electron gain, first electron affinity. First, let us look at the electron gain. How did you draw this graph? I drew it like I gave it in the class also, right? This is group 1. This is group 2. This is 13. This is 14. Group 13, 14. And this is 15, 16, 17. Right? This one is positive. This one is negative. Did you understand that? Isn't electron affinity is same as ionization energy? No, it's not the same. Ionization energy means you are removing an electron from a neutral atom. Electron affinity means you are removing an electron from a negatively charged atom. This reaction is reversed. Whatever this reaction here is completely reversed. That is what you mean by electron affinity. This reaction is reversed, right? Let me show you that. I will write that. A minus gas giving out A gas and electron. Ionization energy means you are removing it from a neutral atom. Affinity means you are removing it from a negatively charged atom. So the same graph, it goes upside down, right? So oxygen is less than that of nitrogen. What can you say? Oxygen and nitrogen. Can you tell me what is oxygen? What is nitrogen? Nitrogen is here. Oxygen is here, right? Turn this upside down, right? So I'm going to turn this upside down for electron affinity. So that's why I want you to listen to this very carefully. Electron affinity. So I'm going to draw that again. So what will happen? Electron affinity, this will be positive. This will be negative, right? That is group 2. Group 13, group 14 would be positive. 15 would be negative. This is 16, 17, and 18 would be positive. Negative, sorry. So you get this kind of a graph. Right? This is 1, this is 2, this is 13, this is 14, this is 15, and 16, 17, and 18. This is affinity, yeah? Positive value is this one, negative value is this one. Did you understand that? So if you look at this example, right? If you look at that example, like all the positives has turned into negatives, right? All the negatives have turned into positives, right? So if you look at this graph, it says the electron affinity of oxygen is less than that of nitrogen. So where is oxygen? Where is nitrogen? Oxygen is here. This is oxygen. Okay? This is nitrogen. So what can you say? That's a true statement or wrong statement, right? That's a true statement. What is positive? What is negative? Positive means energy is absorbed. Negative is energy is released, right? Positive means energy is absorbed, endothermic. Negative means energy is released. So this is endothermic. Endothermic. Positive means that. Negative means exothermic. Meter, you have to understand that. I want you to go through this graph again, right? Graph again, like draw that and make sure that you explain it to yourself, right? This is for a single statement in your paper. Ekka statement ekkato ekaranne. We are explaining this for a single statement that will come in your MCQ. Ekka thanaka, right? So make sure to kind of work it out. So I think that is a true statement, right? C. Right. C. Question number C, part C. Ionization energy of an atom is determined only by its nuclear charge and the radius. What can you say about that? What can you say about that? Ionization energy of an atom is determined only by its nuclear charge and the radius. It is a false statement, but there is another parameter that will control it. What is that parameter? What is that parameter that will control it? One parameter. One parameter. What is that parameter that control it? Electronic configuration as well. Electronic configuration. Did you understand that? Then the D part, the nuclear charge experienced by the valence electron of lithium is less than 3. What can you say? Nuclear charge experienced by the valence electrons is less than 3. There are 2 electrons. Valence electrons is 1. Because of the shielding effect, it observes energy, meaning attraction power less than 3. That's a true statement. And the last one here is the value of electronegativities of carbon and sulfur are same as given according to the Pauling scale of electronegativity. What can you say? Are they true or false? What do you think? Can you remember the values? That is a true statement. Carbon and sulfur and even iodine has a value of 2.5. So carbon and sulfur has a value of 2.5. Did you understand that? Explain D again. Explain D again. What you have is this. When you look at lithium, there are 3 protons. 3 protons. You have 2 electrons here, 1 electron here, right? This electron at the outermost energy is experiencing 3 protons minus 2 electrons. 3 protons minus 2 electrons there, right? So that is what you have. How is oxygen's electron affinity is less than nitrogen? Electron affinity, nitrogen is here lower and oxygen is higher, right? It has a positive value and there's a negative value. Did you understand that? Right. Okay. Right. So, go through the material and maybe this is not the right point to explain electron affinity because, you can in the class we can talk about it. If you come and talk to me, I will explain. Right. Question number 15. Right. Question number 15. The correct order of the first ionization energies of sodium, magnesium, potassium, nitrogen, phosphorus, and fluorine. What do you think? sodium, magnesium, potassium, nitrogen, phosphorus, and fluorine. Right? What do you get? What is that correct order of the first ionization energies? Right. Let us look at this first ionization energies. How do you get this? Sodium, magnesium, right? Okay. So we will sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, and then potassium. Nitrogen is not here. Phosphorus is there, right? So how do you get this one? How do you get this kind of a variation? What is the variation? So I think potassium is the lowest, isn't it? Most reactive one, potassium is the lowest. What is the next one compared to potassium? Right? Then it is the sodium, right? I think it is sodium. Potassium is done, sodium is done. What is the next one? Magnesium, yes. Magnesium, right? Sodium, magnesium. What is the next one? Sodium, magnesium. Then comes, we don't have aluminium that is given. What else? Let me look at this. Potassium, sodium, magnesium. Then you have nitrogen, phosphorus, and fluorine. What is that? Nitrogen, phosphorus, and fluorine. Right. So compared to magnesium, I think you have phosphorus after that, right? Yes, phosphorus. Compared to phosphorus, what is the next one that you have? Nitrogen and fluorine comes in the other period. So compared to nitrogen and then fluorine. Let's see whether there's an answer like that. Potassium, sodium, magnesium, phosphorus, nitrogen, fluorine. What do you think? Second answer? Answer number B? Yes, second answer. Right, okay. So I saw some questions about electron affinity being asked. Yeah, first electron affinity of oxygen is higher than that of nitrogen, or that is oxygen is positive and nitrogen. That is how you compare the positive and negative charges. When you plot the graph, you have a higher value and negative lower value. And yeah, statement wrong. Yeah, okay. So what is that statement? Didn't I read it less? First electron affinity of oxygen is less than that of nitrogen. What is that? Oxygen is less than that of nitrogen. Yes, yes, yes. It says affinity is less than that of nitrogen, right? It is not more than that of nitrogen. Electron affinity is less than. Okay, okay. I apologize. That is wrong. That statement is wrong. Oxygen is, this is not less, it is actually, yeah. So it is more. Oxygen has a more value. Oxygen is more than nitrogen. Yeah, so that means there's a statement that B is also wrong. But the positive ones are considered as like, higher, and then next one. Right, okay. So yeah, whatever the questions you have, you can send it like offline here, and we can discuss this one. Lithium has no third ionization energy. Let us look at lithium. Lithium is the question that is being asked is lithium 1s2, 2s1. It has a third ionization energy, yes, because you can remove the first electron here. There are two electrons to remove. That is the second electron. That is the third electron that is removed. So it says lithium has no third ionization energy. That is a wrong statement, right? ClF4 anion. ClF4 anion, what do you mean by ClF4? ClF4 what? Minus anion. ClF4 minus anion. Yeah, so ClF4 minus anion, chlorine is the central atom. There is only chlorine and fluorine. Like, generally fluorine doesn't become a central atom. Very rare ionic cases are there. But then ClF4 minus, fluorine is the central atom. Yeah, okay. Right. What is that? What is the first ionization energy of O2 minus and N3 minus are the same? No, its energies are not the same. Because the nuclear charge is different, so they are not the same. Right? ClO2 F2 plus, what is the Lewis structure? ClO2 okay. Right. ClO2, what is the other one? F2 plus chlorine, oxygen, fluorine, oxygen. This is the Lewis structure, I think. One, two, three, four, five, six, seven. Yeah. Okay. Central atom is this one. Carbon monoxide Lewis structure. I know why you are asking that, right? I know exactly why you are asking that. We will talk about that, right? Carbon monoxide Lewis structure. There's something else you need to learn in order to do this, right? This is your carbon monoxide Lewis structure. There's something called resonance. So it will pump electrons into this and it will give you a triple bond, right? So we will talk about those, right? Cn minus Lewis structure is this one. Negative charge. There's no central atom here. This is one. S4O7 2 minus, we drew this last time, right? Okay, right. That is enough. Otherwise, we will be working on so many things. Yeah, I'm glad that you have a lot of questions, right? I'm that. But the only thing is this time is like, you might not be able to write answers, all that. Okay. Should we finish the predict the shape of the VSCPR theory in the tute? No, don't do that. That is because I haven't completed it. Once I complete it, then do it. Because otherwise you will do like kind of half-baked thing. The danger of half-baked thing is like, when you try to change this, it's very difficult. When you learn it first, you have to learn it right. Then it'll be there as a kind of mental tattoo so that you won't forget, right? Okay. Right. So there we will stop today, right? And then we will continue this discussion on Saturday, right? Okay, right. Right. Oh, thank you. Good night.